Okay, well, welcome everybody to tonight's Tips and Techniques webinar. I am going to mute everybody here just to keep the background noise down as we get going. And then along the way, if you have questions, you can certainly unmute yourself. So once again, welcome everybody to tonight's webinar. Tonight's kind of a catch-all. We're going to pick up a couple of topics that came up from some people that emailed me some questions. And I got a couple of things that I wanted to talk about as well. And if you're looking for past webinars, you can hop out to my website. I'm linking everything out there. There's also a link on the Next Wave website. You can either find them on YouTube or you can go to this web address. So tonight, we're going to talk about VCarve Toolpath, kind of a review, the basics. We talked about that the last couple of times. But I want to go over a couple of things. In the sign up, just so you know, about half the people that signed up for the webinar tonight have had their machines like less than a year. So obviously they're really new to it. The other half of you have had your machine a little longer, but even some of you are still looking for some basic direction on VCarve and tool pathing and such. So we're going to be talking a couple different things on that tonight. Also, I got a request for some information on how to save out chip carving designs. We did that chip carving with the cutting board. And if you create your own designs, I'm going to show you a technique tonight how you can save those out so they're readily available to you within VCarve, and then you can bring them back into a design if you want to reuse them. And then I'm going to go over some basics on setting up Spoilboard surfacing, and that's why I asked you about the Spoilboard, who's using a Spoilboard. So with that, I'm going to hop over to VCarve, open that up. Well, there's a couple of things that I want to go over tonight. For those of you in particular are new to VCarve, but VCarve has basically, I like to say, like three modes of carving. One is you've got the full V like you see on the left, and that's just full V carving all the way to the full depth. And the way VCarve works is that you'd have the letter V with an outline around it, and the bit carves inside of that outline. And it basically takes whatever the angle of the bit is, and it travels down inside that area until the tip reaches the bottom. So if your lines are wide apart, it's going to go a lot deeper. If your lines are close together, it's going to go shallower. So that's one thing, the most basic kind of carving for VCarve. The other one is a flat depth, which is set up inside of VCarve. In fact, if I open up the VCarve Toolpath that I have here on the right, you can see right up here in the upper right corner. The start depth up here represents the top of your material. That's why it's set at 0. And for most situations, you're going to set it there, leave it there. The flat depth has to do with how deep we're carving. In this case, 1/4 of an inch deep. And then you have your bit selected, and that 1/4 inch deep setting determines how deep it is right there. Now, the third one, I like to call this reverse V carving, because the drawing for this one, what it really amounted to was I have a square like that, select text in a box, go back and select that square again, and then type in the V. And again, we can select whatever font we want for that. That's pretty close. So for basic V carving, the V carve is going to go inside the V and carve around. But if you have another line, it'll jump to the outside of that V and carve around the outside here. Or another way of looking at it, it comes from the outside, it hits a line, it starts carving, hits the next line, and it skips. So between the depth cut here, the flat depth, and adding a border, from that, pretty much all of our V carving designs stem from that. So that's one basic thing to understand about it. The other part of it is that the V carving toolpath actually can use two different bits, a V-carve bit and a straight bit. The straight bit would be used to carve out this flat area around the V, possibly inside this middle V if there was enough room for it to fit in there. But that's called a clearance bit, as you can see on the right side up here. At this case, I have a 1/2 inch selected. That'll be part of the demo as we go along. And then some of these settings right down here all have to do with that clearance bit, much like a pocketing, because you can think of it like a pocket toolpath because it's going to pocket out around here. And the other thing that's worth pointing out is that if your board is not level or it's a little thin on one side, you could end up with results like you see right here. So on the left side of this board, we're right where we need to be, and the lettering looks good, the numbering. But over here, when the board drops off because it's too thin or maybe the table's unlevel, then you're going to get shallower cuts. And yeah, you know, if your board is too high, it'll actually end up leaving round corners rather than nice crisp corners. So two things to think about here. One is, obviously, you want nice flat boards. The second one is, this is where a spoil board comes in really handy, because you have a nice 3/4 inch piece of material, put on a nice flat spoil board, then this helps to improve your chances of having good carving. The T-track table that's on top of the CNC is really meant as a mounting table, and a lot of people work straight off it, and you can, but you'll find that it probably isn't truly level, or it's not co-planar with the action of the router bit. This red line here represents the movement of the router bit, and this dark area, of course, that's the cross section of this side, but this dark area could also represent the cross section of your table. A bit exaggerated maybe, but I've worked on a dozen different machines, and even the industrial machines, the table is not considered to be perfectly flat until you surface it on a spoil board. So it's one good reason to go ahead and add a spoil board and surface it. Now, there are the occasions when you'll have a board that is a little warped or it's a little thick on one side, and even though your spoil board is perfect, you're still getting less than perfect results. In those cases, I have on some projects actually gone in with business cards and shimmed, or playing cards and shimmed up one corner. That works. But the other thing, for those of you who own a Shark, you have available what's called Virtual Zero, or Virtual Zero Unlimited if you're using the Ready to Control software. And Virtual Zero and Virtual Zero Unlimited, you actually go into this board and you scan some points on the board using your touch plate, and it actually takes your tap file, your G-code file, and it warps it to fit your board. It's quite effective, and I've used it on a handful of projects when I've had boards that are slightly warped, or maybe they were a little bit thicker on one side. So if you haven't used that, I did a demonstration of that, or an explanation of that, in the pendant webinar. So if you haven't checked that one out, you can certainly check that out and find out more about it. And maybe someday we'll even do a fuller demonstration during one of these webinars. The third part I want to look at is understanding how the VCarve Toolpath works. So what this first picture here is showing is that carving this star, if I'm just using the V-bit, I'm not using the straight bit, the V-bit will go in and creating these furrows, and this, again, the V-bit is just using the V-bit to clear it out. So if I open up my V-bit settings, let's move them over here, like, there we go. Okay, so right here underneath the VCarve settings, we've got pass depth. Of course, that's how deep it's going to cut each time it takes a layer. The final pass step over, that's the, like your finishing pass. Down here at the bottom right here, that's what the bit is doing right here. It's stepping over. 2% is pretty common for a 90-degree bit. It's only stepping over 0.010 of an inch because it's only using the tip of the bit to do that final carving. The clearance pass step over is in regards to what you see here, where it's more like the furrows, and that's basically hogging it out. Now, 2 and 20% are the default settings that come with VCarve, and they work. If you never change them, they'll work fine. However, there are times where you may find that you can actually speed up your carving by increasing this to 40%. It's going to leave a much wider furrow, but groove. But by the time it gets done, when it goes back and does the final carving at the bottom, you're still at that 2%. So it's still going to clean that up nicely. The other thing I have found that is with a 60-degree bit, I sometimes will take that down to 10% because I want it to remove a little bit more material. But if you're just starting out, if you just stick with the 2 and 20 for most of your V-bits, you'll be in good shape. Now, after the V-bit, if we're just using the V-bit, the final cutting that it does is it goes around and cleans up the corners, and you can see the layers here with this red arrow. There's still some stuff left in the corner, but then the bit goes around, and this is part of the magic of V-carving, is the tip of that bit actually lifts up inside that corner, giving you that sharp edge, which again is different than if you were just to use a profile outline around this. You'd end up with rounded corners. So with that, I'm actually going to run this star over here. I have these settings up here. We're set at 1/4 inch for flat depth. I'm going to use a 1/2 inch end mill to hog out the middle area. And then on the end mill, you've got options. One is a raster, which basically follows the profile of the shape, or I'm sorry, the offset. The raster, by default, will go left and right. And if your wood grain is running that direction, then that's a good option. Now, if we look at the wood on the right over here, it's actually running vertical. So if we wanted our bit to run vertical for the raster, you could change that raster angle right here to 90. I'm going to leave that on a raster. I'm going to put that on climb cut, which will there'll be less chipping. And then I'm going to put a 1 inch, actually, let's put like a 2 inch ramp on that and calculate that out. So now in the picture here, the red lines represent where the router bit is traveling above the material. The aqua lines are the plunges where it's going down in, and the blue lines are where the router bit's actually cutting. These check boxes control the visibility of the tool path. So if I uncheck the last one, this is just the tool path for the clearance bit, or that 1/2 inch bit. So let's go ahead and we'll preview that. And there you can see how the bit is moving with the grain, and it goes around, trims up the edge. And it actually allows for the angle of the bit. That's why you have that stair step. Now the V bit, let's go ahead and we'll just, I'm going to slow this way down. So you can see how it's going to go into the corners and start doing some clearance cuts. So that's the clearance cut with the larger step over. It'll do that at each layer. So now it's doing it on the second layer. Speed it up a little bit, and it's going down to the third layer. Now, as it gets down near the bottom, notice how it's going up in the corners to clean up those corners. Up, and it gets the last, it goes up in the corner, cleans it up, and then it goes around and cleans up those corners on the flat area. One of the important things to understand about V-carving of this type is you can see there's a little texture in there, and that's because the tip of the V-bit ended up having to go in there because the 1/2 inch router bit would not fit into that area. Now, if you have a critical carving that you actually want to try and get a little more cleanup in there, I'm going to double click on the icon right over here to the right, and that'll open up that V-carving or that VCarve toolpath again. And I could actually go back in and add another bit. So let's go in and I'm going to find an 1/8 inch. Take a tiny bit here. We'll hit apply, select that. And you notice how they're stacked here now. It automatically stacks them largest to smallest. And I'll calculate that. And now we have 2 clearance bits. So the first bit is the 1/2 inch bit. So we can preview that. Just like we did before, it takes it all the way to the bottom, leaves a nice flat bottom. Now notice the 1/8 inch bit, it's just going to go into the corners. So it's just picking up those areas that were not able to be carved with the 1/2 inch. So we'll preview that, and now it looks much sharper out there. And now the V bit, look at how little the V bit has to clean up. So let's go ahead and preview that. And now you can see we have just a little tiny bit in that corner. So depending on your project, depending on your design, sometimes adding a second clearance bit makes sense to help clear those areas up. If you're dealing with a carving on a piece of furniture or a nice piece of like a wooden box or something, or you want really clean cuts, I'm going back in here with like a straight chisel or a straight carving tool and just kind of scratched or scraped rather that fuzz off and got a really perfect bottom if you want to go that far with it. But that's some of the basics of using VCarve. There's more we can go into, but we won't do that tonight. We'll look at that sometime in the future. But before we leave the VCarving topic, any questions from anybody?
Yeah, Randy, when you added the extra, Desi here, when you added the extra clearance bit, did the second bit keep the same settings as the first bit as far as the characteristics of whether it was going to raster or anything like that?
Good question, Desi. Yeah, let me open it back up here. So the second bit, first off, the pass depth, step over, all of these settings, that came right out of the tool database. So that is independent based on that bit. But these other settings down here, notice how I've got the 1/8 inch bit highlighted?
Correct.
None of these options are available to me except I can add a plunge, which I should do.
Yeah,
So
that's what I saw.
it creates its own, it kind of determines what's best, and it's probably going to be a kind of an offset as it goes and cleans it up. So if I click on the first one, the 1/2 inch, now these settings are available to me. So it's specific to the bit.
Yeah, I had to learn that when I was doing raised text and had three different clearance tools or 3 different bits to go in to make sure I didn't have any fuzz around my letters and things.
Right.
Okay, thank you.
Yeah. So Vectory's done a pretty good job. If you start clicking on these, you'll see some things gray out, which means they're simply not available. So let's go ahead and take one more peek at that. So again, that's the 1/8 inch bit, and it's pretty much doing whatever it needs to do to get that area cleaned up. Good
Quick
question.
comment, Randy.
Anybody else?
Yeah, quick comment.
Yeah, Robert.
I've been doing this for several years, but I always do my V carving first and then clean up.
Actually, that is a good suggestion. There are times when doing the V carving first makes sense, and that's fine. They come out in this order, but you don't have to do it in this order. Now, let's take a preview of this and see what happens if I reset this. I'll do the V carve first. So there's the V carving. That's just along the edge. And then, go back in and we could probably do the 1/2 inch would be a good choice to do. And that just leaves those corners. So then the 1/8 inch bit is going to come in and clean those parts up. But there are designs where when you do your straight bit, you end up with all these little, think of them almost like little islands of material. And if those islands are fairly small, they could chip off the top edge of it, and then you could lose your detail. Where if you go do your V carving first, it leaves a much crisper edge to it. So bottom line is you could do it either order, and sometimes it actually makes sense to do the V-carve bit first. So thanks for that, Robert. Last week, we've been working on this cutting board, and the question came up because I made the comment about saving these out as templates and reusing them again. So I want to show you how you could do that. If you go over to the left side over here on your drawing, you'll see a column called clip art. And typically what comes up here is you've got your clip art library from Vectric, which may have, you know, various types of designs. Here's some 3D stuff. But you also have a local file tab up here. And if you click on that, your folders that are on your computer appear over this left side. And let me bring up my folder. So there's my desktop folder right there. And you can see I've got a file that I created on my desktop called Chip Carve Designs, and that Chip Carve Design shows up over here as well. So to get files inside that so I can use them in here, quite simple actually. Let's go to the Design tab. I'm going to go to the bottom. So what I want to do is I want to create another VCarve file. Now, if I click on this icon right here and click New, or if I click up under File and click New, what's going to happen, it's going to close out the one that was open. So the one that I just had open there is gone. So I'm going to say okay, because I'm going to use this one anyway. Let's hit. But if I look at the bottom here, I no longer have, when I'm clicking on that icon at the bottom of my window, these little 3 icons pop up down here, and I no longer have the one for my cutting board. So I'm going to right click down here, and then I get my list. So let's open up the cutting board. So you can have multiple VCarve files open at the same time. But to get them open, at least on my computer, I have to work from this bottom menu. And like this is the VCarve one we just used. I don't need that, so I can close that. Let's see. There we go. It's saying, do you want to save? I'll say yes. Okay, I'm going to go back down here again. Now, if I want to create a fresh file using this approach, I right-click on it, and I simply click here. That will create a new file without closing the current one. So open this up. To say okay. And now I'm going to take and shrink these down a little bit so I can see a couple of files at the same time. And then bring my cutting board file over here to the left, like that. And let's get rid of this one for now. There we go. So we've got our 2 files. Don't need this. So this is what you want to get set up. You want to get your master file where your design is, and then you want to create a temporary file here that you're going to save your designs to. So I'm going to go over to the left side over here, I'm going to select that design, and you see I've got it grouped. I'm going to right click on that or hit Control C, copy that, go over here, right click, paste. And I think I'll just center that on my project area like that. Then I'll do a save as, and I'm going to save it to that file that I've created. This file can be any place that you want on your computer. I'm just going to save it to that chip carve design file, and I'm going to call that chip carve fan design. Say OK on that. And just hit save just to make sure. Then I'm going to select that, delete it, grab that star, Control C for control copy. Over here, I'll go Control V for control paste. That puts it right down here. Let's center it. Then I'm going to go back up here, do a save as, and we can see our first one. So here I'm going to call this chip carve star medium. And we just saved a file called star medium, and I'll just continue doing that with, let's delete that, grab this one, go over here, paste it, center it, save as. Let's do star small. And then the last thing I want to do is let's save, copy that, delete that star, paste that design. And it's okay that it's bigger than our background. It'll still work out. Then I'm going to hit save on that, save as. And call that triangle edge design. Okay, so then I've got that. So I'm just going to create a new one over here. Make it a little bit bigger. Okay, if I go back out to my folder that on my computer, you can see our 4 chip carve designs are in there. So those will now, because those are CRV files, I can now simply go straight into my clip art file here, go up to my local files, and there you can see all of them right down here. So if I'm designing some new chip carving, I can grab whatever I want here. All I have to do is just grab it and drag it over here. Grab it, drag it over here, and I can drag all those over there. And now I can work with those components. You know, if I need another chip carve, I can grab another one. And so it's a real handy way to build libraries. And as you can see, it's all, you can structure multiple folders in here. You got chip carve design, you could have sign design, you could have 3D art design, whatever you wanted, you could design files. What's going to show up in here will be VCarve or 3D model specific files. So some bitmaps, some PDFs will show up in there, some 3D carvings, but relative to the kind of design work that we were doing on the cutting board, that's how you would save those designs if you wanted to create your own library of designs, or if you're designing, if you just want to save out your components of some other project that you're working on, you can save the components out. Now, if you come across a complete project it would also be saved in there. In fact, if I go to this one, and let's save this as, and let's just save it, cutting board demo. Yep, let's just save that. Let's see here. I gotta find the right folder. Let's just put it inside that one. Back out of that a second, go back into it, and there it is right here. Our entire design. I could even drag that whole design in. Some layers you're importing are invisible. Would you like to show them? I'm going to say no. Okay, let's go and see what we got for layers. Okay, right there we go. There's that detail. So in this case, because it was that entire file, everything imported. So in this case, this file here has all of these layers. I have lots of other information in this file. If I look at all those, I had all this other information from last week's class, and all that information was part of that file. So when I dragged it over here, in fact, all that information came in with it. So be aware of that when you're dragging in an SCRV file or copying it over like this, it brings everything in. That's why when I was setting up these, I did them as individual CRV files or individual VCarve files. So that way, when I bring them in, that's all that's coming in. It's just that one component. Talk a little bit about Spoilboards tonight. So first off, that poll we took earlier, I'm going to drag this over, see if you guys can see this. I think you should be able to see that. So for those of you who's weighed in, it looks like, 19 out of 23 people are using their own Spoilboard. And we've got a few people that are using the segmented one from Next Wave, and a couple are using, or one person's still using the T-slot table. So that's a good topic. What you see here in the picture here is this is my HD5. I've got an HD 500 and an HD 520 in my shop. I like this little machine for smaller projects. It's just easy to work around. I've got a 2-horse spindle on this one. I've got a 3-horse on my other one. This machine here, actually, if we look down here, I actually have the black segmented Spoilboard from Next Wave. I, however, glued a piece of 3/4 inch MDF to the top. And here's my rationale for that. One is I like to have a continuous top for carving on and cutting on. I'm also not a huge fan of the clamps that go inside the T-slots. They're really convenient, but they just tend to get in the way, and I can't always reach the project I want to clamp. So I tend not to use those. So I prefer this base. Also, I like it because if I want to screw something down to it, I've got 1.5 inches of material to screw into. It works really well. Also, the black Spoilboards that come from Next Wave, they come with T-nuts, counterboard, so they go on real easy. And then I just I put a bunch of tape around this whole thing so I didn't get tape on the red table or glue on the red table. And then I just glued down my MDF right to those. It's essentially a permanent installation. If I ever want to take this off, I could go and just eventually, as I use the Spoilboard router bit and take this top off, I'll just get back to these black boards that I would expose the screws and the bolts, and I could take those off if I wanted to. But most of the machines I've worked on, this is kind of the setup. A lot of machines, what I'll do on the bottom, rather than using the black MDF, if I don't have those segmented Spoilboards, I'll just put a piece of plywood down. I like plywood because it's flat, it's stiff, and also if the screw goes through the MDF into that plywood, it makes a really good bite. one little thing to consider there, use just a standard grade cabinet plywood. Don't use a rough exterior plywood. Standard grade cabinet plywood is a great idea. And also don't use Baltic birch, because Baltic birch is so hard, it's kind of like screwing into aluminum. So something you can actually screw into. Now on this table, I also run a router bit around these three edges and trim those up, so I have an exact X and Y alignment on that, for especially on the left side over here. That's my X0, the front is my Y0. Now the question came up from a couple of people about setting up a surfacing toolpath for this, and it's really quite straightforward. We'll talk a little bit about router bits here in a bit, but basically set up a file over here which is the size of your router table or of your CNC table. In this case, for my HD 500, it cuts almost 13 inches wide, not quite, 12 and a half comfortably. And the length is, the depth of it is comfortably 24 and a half. So that's when I set it up, and basic set 3/4 inch thick. I'm using a lower left data point for this file. Say okay on that. Let's turn off a couple of layers here. There we go. Just work on this. And then I draw a rectangle just around that table like that. And I've already got my surfacing, so I'm going to use that, just simply a pocket toolpath. And I typically set that up as a default at 0.02 depth. But then my surfacing bit, let's open up and take a look at that. Let's see if I have that in here. I don't have it, so I'm on a different computer right now, so I don't have that in my tool bits. So let's add that in here. End mill, we'll add an end mill. Diameter 1.25. 2 flutes. Create the settings. Now for the path depth here, I typically keep that, like I said, at 0.02. I rarely take more than that off. Spindle speed, I'm going to set that at 18,000 for my machine. Feed rate, I'm going to keep that fairly fast. And then step over for a spoilboard bit, I like to put that at 80%, so it takes a large amount off. And then up here, I'll actually go into this little icon here, and I'll just rename this. Take off the tool type there and type in spoilboard bit. And that just renames it. We're going to use those settings. It says what already exists. So let's take and remove that bit. Go back and get that one. Now we have our spoilboard bit. Now it's just a basic pocket setup. I often will use offset rather than raster. I'll explain that in a minute why. You probably don't need a ramp move, but I'll put one in here anyway. And let's select that vector there. And I name it HD 500 surfacing 0.02 to remind me how much I'm taking off. That's okay. So there we can see the pattern that it's going to cut. So there, for some reason, left a little remnant in the middle there. I don't know if that'll be real or not. This may be one of those rare occasions where the visualization here isn't accurate. However, notice that in the corners here, it definitely left something. So what I'm going to do is go back to my design here and I'm going to add some dog bone fillets, 0.625, that's the radius of our bit. And just simply click 1, 2, 3, and 4. Then I'll go back into this and I'm going to right click, recalculate, and it's all good. Let's go to the 3D view, reset that, preview it again, and now it took those corners off. Now, I don't know if this is going to show. I haven't noticed this before, if this middle is going to show. It's a pretty small little strip there if it does. Let's look at the 2D view for a minute. And let's look at the solid view. So there, oh, there you can see it probably amounts to nothing. But if you do find something like that happening, here's one little trick that you could do. I could go back inside my toolpath. I could change my step over. Let's take it up to 85%. And calculate that. Okay. Now I'm getting this error. The question is why? Well, I could look right now. If I look at that area, let me cancel out of this. Notice how I actually have 2 vectors selected. So that's an extra vector. So let's get rid of that one. Go back in and let's just recalculate this just to double check. Okay. Well, in this drawing, that little white line disappeared. Let's see what happens in our preview. And that little middle area disappeared. So that's just a good example that if you don't see what you want in this drawing is to go back and make some adjustments till it previews the way you want it to preview. And that's pretty straightforward. Again, you're going to zero your bit to the top of this, and then you're going to run it. And the first time you zero, or the first time you do a spoilboard for the first time, I usually try and find the high corner or the high spot of my spoilboard and zero to that point. Because if you end up zeroing to the low corner, you may end up cutting off a 1/16 or even an 1/8 of an inch on the high corner. That can be a little bit aggressive for some of the setups. The last thing that I've added to the spoilboard is I've added a grid, and creating a grid setup is really very simple, actually. Let's take those lines and delete these. Actually, I can delete all these. Let's go just like that. So to create a grid very quickly, you could just take a line, and we're going to go turn my snaps on up here so it goes straight like that. And I'm going to make that the length of my spoilboard. So I want that to be 24.5 in height. I now want to position this, and I'm going to use a 2-inch grid. So I'm going to set this up for moving it. Lower left corner. Actually, let's go lower left corner. X position would be 2 inches and Y would be 0. And that's going to move this line right over to that location like that. I can then control copy, control paste, then hit the 0 key on my keyboard and rotate that twice. And now this one, I'm going to change that to 12.5. Move that X0 because I want this lower corner here to line up with the left side. And Y height is going to be 2. And so there I've got my basic lines. From here then, all I need to do is go in to my array copy. And in this case, we want, let's try 10 rows. That's going to be 22 inches. Or yeah, it's going to be 22 total inches. Let's see if that works out. Let's go 11 on that. And let's do a Y spacing of 2. See how that works out. Almost to the top. Let's go one more on that. And there we go. And we're going to do the same on this one. Well, in this case, we're going to have 1 row. And we're going to do 12 to the right. And we're going to go 2 in the X on the offset. And that was too many. Obviously, I only need 6 there because I have a different tool. There we go. So that's the grid work. I now can select all that, group it, and I already have a grid toolpath set up here, which for this, I am using a profile toolpath. I'm going 0.05 deep, and I'm using a 60-degree router bit on that. So I'll select that group. I'm going to cut on the line. You can see it's going to cut it 1 pass. I'm going to add a little bit of ramp to each one of those. Calculate that out. Preview that, and there's our grid work. Now, let me bring up that photo I had earlier. So that grid work resembles, this is HD 510 that I had at one point. And you can see that grid work, how that looks on there. Now on this particular table, my spoil board, I left it about 1/4 inch larger than my actual cutting area. So this corner right here is actually my homing, or my 00 for my home. But in this case, I left a little border around it because I'm going to be working with inside that grid work. On the one that I just designed up here, my grid work goes right to the edge of the X and the Y, and I will eventually add that to this table, because of this table, like I said, I actually ran a trim all the way around the edge. And the way I did that, and that's where that other square vector came from that I deleted. So I'm going to add it back in here. 12.5, let's see, width is 12.5, height is 24.5. So this edge pass, there you can see that edge pass, how I'm going out around the material. My router bit is actually passing to the outside of that vector right here, that vector right there. Now, it's important to understand that on Shark tools, you have about 1/4 inch of gutter, let's say, beyond your homing area, beyond your X0 and Y0. So there's just enough room to run 1/4 inch bit up around outside of your cutting area if you so choose to trim your table. Most of the times with the tables that I set up, I don't do that. I usually just leave it more like this spoil board, and then I may add a grid, which just helps for quick alignment. These circles on this table represent the location of the bolts that are below that are holding the table, the plywood to the table. That way, if I'm going to put screws in here, I know where that bolt is so I don't run into it. Many of you have probably also said there's lots of great ways to add to this table. People will put dowels in here for quick alignment. There's a ton of ways you can modify a spoil board, and that's one reason why I'm a big fan of spoil boards, because you can customize them. If any of you tuned into the Vetric user group meeting about a few weeks back, I did a demo on there where I showed how to build a little sliding lid box with figure joints. And I actually cut right into my spoil board to make pockets to lay my material. So I actually use my spoil board as an actual jig. So for me, a spoil board is very much a working surface. Now, in this case, once I get down to maybe an 1/8 inch or a 3/8 or maybe a 1/4 inch thick here, I won't take it all the way down to the black. I'll just glue another piece of MDF on it. So whenever it gets too thin, just glue another piece of MDF on it and you'll be good to go. Well, hopefully that helps those of you who are asking about spoil board surfacing. I know there's a lot of experience here in the room tonight. So anybody else want to weigh in on what their spoil board experience has been like?
Yeah, Randy, Bob again.
Yeah, Bob.
I have a, oh my God, VCarve Pro, or VCarve Pro, a Shark Pro, which is probably 15 years old now.
I just worked on one.
Been
just taught a
running
class.
fine.
I just taught a class on one. Yep.
But I leave 5 inches bare on the near side and put spoil board on the other half. And that probably covers 95% of what I do, either on the table or on the spoil board, without covering the whole table and committing myself. And it's worked out.
That way you're able to use the clamps for some of your projects.
Yeah.
That's a great idea.
When I do signs, when I make most of my signs, I do right on the table.
That's a great idea.
Oh. And my spoil board is removable. So
yeah, Shark, what you see here at the table, there's about 6 inches in front of this that isn't cutting area. So if I needed to put a clamp on here, there's plenty of room in front to put a clamp and still keep my material within the cutting area. So that's a great idea, Bob. Anybody else?
Yeah, Ryan, it's Keith.
Yeah, Keith.
I do a couple things. I've got a 510. And I've actually put an air weights vacuum table on it. And I put which I'm always afraid of chewing into. So when I want to use a spoil board, when it's not something I can use the vacuum for, I put my spoil board on top of the air weights table. And that way I've got I carve a way into it. And I also, my grid I put on with my laser.
Okay, sure.
It makes a little bit sharper line.
Yeah.
It just works out. And I had trouble at one time because I started out using the V-bit way like you did it there. And I was having trouble with the double-sided tape spalling the MDF off. And I was getting chunk, shallow chunks, but still all of a sudden you got holes all over the surface. And so I just decided that I use the laser, and then I'm not exposing any edge, if you will.
Oh, I see what you're saying. Sure. I just surfaced this one, I guess this week actually, before I started a new project. And I'd used it for a couple of months and it was pretty chewed up, and I had to take about a 1/16 of an inch off to get it clean. The real trick is that when you're doing your cutting, that you can see on this one, is to try and keep your through cuts to a minimum. That's actually a little deeper than I usually try to do, but I mismeasured the thickness of my board, so it went a little deeper. But usually by the time, in a couple of months, this whole table will start looking like that, and then it's time to surface it, which is why having a surfacing toolpath set up. And I typically keep the surfacing toolpaths handy because rather than recreate them every time, I just keep them on my computer and run them.
Yeah, I do the same. I've got a program. I just drop it in, surface it, and then just throw my laser up. I've got a 7-watt laser. Just throw my laser on and regrid it and go back to work.
Got it.
I have the micro jig spoil board set up on mine, and that's the downside to it, is that you can't really surface it.
Ah, okay. That takes some special clamps so you can add to it though, right?
Yeah, micro jig, like it takes, like they have a bunch of different type of clamps that go to it, or there's like a kit that I bought that had them all in it.
Oh, great. Yeah, again, you probably have surfed around that out on the internet. There's a lot of solutions out there. I'm pretty basic with mine because I do such a variety of projects. So I just use a pretty basic spoil board. But for surfacing, though, people have often asked, what about bits? And I came across these two Freud bits. I don't use a lot of Freud bits, except these two I kind of like. This is a 1/4 inch shank, and this is a 1/2 inch shank. They're really economical for what they do, and all you're doing is taking off the top of that MDF. I met with Freud a couple of years ago at their headquarters, and at the time they were calling these mortising bits like you see there, but I think they actually changed the name now. But that's all you need, and whether it's a 1/2 inch or 1/4 inch, if you have a 1/2 inch spindle, I definitely would go with the 1/2 inch. It's certainly stouter. I've also used this white side right here, either 3 or 4 bit, and it's really nice too. And it's probably about 1 inch to, yeah, I'm not sure this one, but 1 inch, 1.25 inches as well. That works really well, also economical. And if you have the larger, like the 520 tools, these are like 2 to 3 inch diameters from Amana. I have one of these for my 520. It's certainly a lot larger, and I would only recommend that if you have the 1/2 inch collet, which would be the 3-horse spindle. Most people using these bits are using these on a 4x8 machine. So they're a little bit overkill, even on the 520, but they do a nice job. Notice, however, that this bit, what's unique about it, it's only a really end cutting. It's only cutting on the tips of those. There is no side cutting, really. I mean, we do have the burr right here, but if anything, it's going to cut an angle, where the Freud bits and this white side actually do have a little edge cutting. Now, does that matter? Not for a spoil board. It doesn't matter. It's just gonna, but if you were surfacing wood and creating kind of a rabbet, that's where these other 3 bits really come in better. And of course, there's really, as you can see here, this is just part of Amana's selection. And that's just one brand. So they kind of have a surfacing bit for every occasion. But the point of this is that you don't have to be too fancy with it. Even though people, the smaller machines use just a 1 inch straight bit to get the job done. Anybody else out there with spoilboard stories?
Yeah, Randy,
Nice.
no story, but I'm sorry, Bill. I'm sorry, Robert. No story, but I think there was a nice tip with the little dog bone to take care of the edges, because I've always used the oversized rectangle or an allowance to clean up the edges
Yeah.
that were left.
Right.
I have a Shark 2, which is, I believe, it's the same size as your 500.
It is. Yep.
Except it has a gantry that's a little different. But yeah, that was kind of neat. So I can just do a regular rectangle and add the dog bones and take care of my edges.
Yeah, so another thing to think about, I know when I first joined CNC years ago, I got really nervous about, well, am I going to run into the side of my machine? But let's just look at how a router bit. So we'll take 1.25 inch router bit like that. And the one I have has so that's the shank, and that's the router bit diameter right there. So if I group that, so that router bit, as that travels around the table, you can see how it's going to go out into that opening. And then down here, it's traveling right here. Well, you mentioned, Desi, about using an allowance. And if any of you aren't familiar with that, that's this pocket allowance right here. So let's add, and let's see here. Let's see, pocket allowance. Let's add a -0.25, if I'm thinking correctly here. I went the right, yeah, there. So now you can see how it it's overhanging the edge of that. Yeah, so it's overhanging the edge of that now, which if we were to go back in and take off the dog bone in that quarter, like that, recalculate that. So you'd have to have a 1/4 inch overhang to get around that corner. So certainly another option. And that's what Desi was doing. But the other thing now is that this bit goes over that far. What's comforting here to realize this is the router, your machine could actually travel over all the way to right there. So your router bit actually can overhang that far around the edge. That's why this allowance or the dog bone works out, because you're not going to run into the hard stop on the side of the machine. So just be aware that if you have any other projects you're working on, you're like, oh, I'm getting so close to the edge of my machine, realize it's the middle of your spindle or the middle of your router bit that is the true limit. And so that's where these larger bits have some advantage, especially for spoilboard cutting. And that's why on this machine here, I'm able to surface this border out here, even though it's beyond my cutting, my standard cutting area, because with the large bit, that wing just goes over to the side. So again, whatever your preferences are for that, but that's just another option. Anybody else? Well, guys, if there's nothing else tonight, everybody, I think that'll wrap it up. Next week, we're going to start a new project of the month, and we'll talk about designing that.
Thank you, sir.
Thank you.
All right.
Thanks for coming out tonight, everybody.
Thank you.
Thanks,
Take care.
Randy.